I'm Pei Tong. I'm a fifth-year PhD student at Berkeley. I worked on this project with Qingyi, Gong, Bjorn, and Yang when I was a student researcher at Google DeepMind. Feedback is essential for guiding designers towards improving their UIs, but human feedback is not always readily available. And while automated methods can provide instant feedback, they have other limitations. Traditional or non-LLM-based methods have limited generalizability to different dimensions of evaluation and require large amounts of training data to evaluate a narrow aspect of the design, like task completion time. So we turn to LLMs, which offer strong generalization capabilities to different UIs and dimensions of evaluation without any training required. So despite their strong generalization capabilities, LLMs also have room for improvement when it comes to UI feedback. As found in our prior work, these general-purpose LLMs have some fundamental gaps in knowledge when it comes to UI evaluation, such as poor knowledge of popular design conventions and the failure to properly prioritize when guidelines clash. So we hypothesized that a targeted dataset of high-quality UI design feedback can be applied to enhance the performance of general-purpose LLMs in methods like few-shot training, which will allow LLMs to learn the specifics and nuances of UI evaluation. So while there currently exists a lot of UI datasets, like the Clay dataset, which contains UI string data and semantic labels, as well as UI datasets augmented with user data, like eye tracking and task traces, at the time of this research, there lacked a large enough dataset of UI design feedback to comprehensively capture the knowledge required to carry out high-quality UI evaluation. So we weren't the only ones who recognized this problem, since Jason also talked about a UI dataset for design assessment. Our dataset focuses on UI design feedback, and we also use different approaches to collect and model the data. So here's an outline of our approach. We first collected and analyzed UICrit, a dataset of 3,059 design critiques and ratings provided by experienced human designers for 1,000 mobile UIs. So this dataset is publicly available for you to download at the link below or by scanning the QR code. We then demonstrated UICrit's utility by using it for few-shot training of Gemini 1.0 Pro to generate design feedback for UI screenshots. Finally, we conducted a user study of design experts to validate the performance improvement of few-shot training over zero-shot or without usage of UICrit. And we also compared its feedback quality with those from human designers. So I'll now talk about our data collection method and analysis. So here's the illustration of our data collection method. We recruited 7 experienced designers for annotation and randomly sampled 1,000 mobile UI screens from the Clay dataset. For each UI, an annotator provided feedback data that I'll talk about in detail in the next slide. So we provided the annotator with 3 established sets of design guidelines to ensure that the critiques are grounded in best practices. Also, to supplement their critiques, we pre-generated design critiques for each UI screen using zero-shot multimodal Gemini 1.0, but since LLMs can make mistakes, we asked the rater to filter out the incorrect LLM critiques. So they do all this in the annotation interface that we designed. So next, I will show an example of the feedback data provided for a UI. So here's the example of feedback for a UI screen in the dataset. It consists of the main task this UI screen is designed for, a list of natural language design comments, corresponding bounding boxes that contextualize each comment with relevant regions in the screenshot, and finally, ratings for aesthetics, usability, and design quality. So these ratings were based on the design comments for that UI and a rubric we designed that explained and broke down each rating dimension into specific characteristics to look for. So we analyzed this dataset to better understand its characteristics. We first computed high-level quantitative metrics. So as mentioned before, there are 3,059 design comments for 983 mobile UIs. So some of the screens were well-designed and did not have any issues to comment on. So this means there's an average of 3 critiques per UI, and the majority of the comments were made by humans only, and the rest were made by Gemini or covered design issues mentioned by both humans and Gemini. So we found that only 13% of the comments generated by Gemini were validated, which implied a strong need for targeted training of general-purpose LLMs. So the histogram shows the rating distribution for each dimension, and we see that they all generally follow a normal distribution, with an average rating around 6 out of 10. So we also did some in-depth analysis, and one of them was to characterize the types of UIs represented in this dataset. So we did this analysis by using k-means clustering of the embeddings of the UI task annotations, and then qualitatively analyzing the UI tasks in each cluster using grounded coding and thematic analysis. So the clustering results for UI tasks are shown in this plot, each labeled with the broad topic that we determined qualitatively, and it includes topics like user account management, location and travel, etc. So we also ran this analysis on the design comments to characterize the types of design issues covered by the comments in this dataset, which is shown in this plot. So the broad categories of design issues we identified include things like layout, text readability, color contrast, etc. So I will now talk about how we use UICrit for modeling with few-shot training. So the data available in UICrit could be used to automate two types of feedback generation tasks. The first one is where the designer will mark a specific region in the UI screen that they will like feedback on, and the model will output a comment for that region specifically. The second task is that a designer will ask the model for feedback on the entire UI screen, and the LLM will return the design comments contextualized with bounding boxes as well as numerical ratings. So for the rest of the talk, I'll focus on this second modeling task, and you can refer to the paper for the first modeling task. So we developed a lightweight few-shot learning setup to model the second task. We found that separating design comment generation and bounding box estimation into two LLM calls yielded better performance. So we separated them and tuned each prompt individually. For design feedback and rating generation, we use an LLM that takes in a prompt instructing it to generate design feedback, a screenshot of the UI to be evaluated, and few-shot examples selected from our dataset. So we tried various few-shot selection methods as shown in the table here, like selecting screens from UICrit based on visual similarity to the input UI, by task similarity, or a combination of both task and visual similarity. And we also tuned a number of few-shot examples. So we found that selecting based on both visual and task similarity with 8 shots, which is the maximum number of shots that would fit in the context window, had the best performance. So this could be because these UIs are the most overall similar to the input UI. For bounding box estimation, we use another LLM. So this LLM takes in the output from the previous LLM, a prompt instructing it to generate bounding boxes for each comment, and we use visual prompting techniques to help with bounding box estimation. So specifically, we added a coordinate axis along the edge of the screenshot for the LLM to reference to help it estimate the bounding box coordinates. Finally, I will talk about how we validated the dataset utility in improving design feedback generation. So to formally validate that our few-shot setup actually helps the model generate better design comments, we ran a user study with 6 design experts. They rated the comments generated by 3 different conditions. The first condition is without usage of UICrit or zero-shot prompting. The second condition is our best performing configuration for our few-shot setup that I just described. And the third condition is human-generated comments taken directly from the dataset. So the experts rated each comment as invalid, partially valid, or valid, and ranked the generated sets of comments for each UI based on overall quality and comprehensiveness. So the histogram shows the rating counts for individual comments, and we found that the zero-shot baseline method had the highest fraction of invalid ratings and the lowest fraction of valid ratings, while the few-shot setup had fairly uniform ratings, and the majority of human-generated comments were valid. So some human-generated comments were rated as invalid, likely due to the subjective nature of design evaluation. So the table shows the average comment quality score, where our setup significantly outperformed the zero-shot baseline by 55%, and was also ranked higher, like the lower the ranked number, the better. However, its performance is still not as strong as that of experienced human designers. So while our targeted few-shot and visual prompting method improved over the zero-shot baseline, it only utilized 8 training examples from the dataset. So the next step for future work is to fine-tune an LLM on all 1,000 UIs, which may yield an even larger performance gain and potentially even close the gap between LLM and human designer performance. So regarding broader applications, this dataset could be used to train a UI critique model that is design tool agnostic. Since it would only need to take in the image of the UI mockup, it would not depend on a tool's internal representation of the UI, which would vary by design tool. but this enables flexible integration into any design tool. So in addition, this dataset could be used to train a model to critique and score the output designs of UI generation models, serving as a reward signal. So this is very valuable as the UIs generated by these models often fail to adhere to UI design principles. So to conclude, we collected a targeted dataset of design critiques, corresponding bounding boxes, and design quality ratings from experienced designers, and then applied this dataset to automate UI feedback generation with a novel prompt design that includes targeted few-shot sampling and visual prompting. And design experts confirmed that this technique produces higher quality feedback than zero-shot prompting without usage of this dataset, which validates UICrit's utility in enhancing automated design feedback. Thank you.
James Landay, Stanford. I understand why one might want to do these automated techniques on screenshots, but when I teach interface design, a lot of what we talk about is time and interaction and the flow between different screens. And I'm wondering, how does your future work and these techniques start to get at those kind of issues that one would find rather than just what's on a static screen?
Yeah, it's definitely possible to, collect, feedback and rating data on, I guess, on interactions. It will be like task flows, or kind of like a series of screens. And you can, definitely feed the sequence of screens into, multimodal LLMs and, I guess, train it to, give feedback. As well as, I guess, show that to, the human annotators for them to, provide feedback on the interaction, too.
So do you think the same techniques are going to work, or is there some big difference that you'll need to think about when you do that?
Yeah, I think that the techniques could pretty much be extended to apply to interactions.
Okay, great job. And here is the Alex from the Singapore Management University. And I noticed that in your evaluation, there's a huge gap between the model and the expert evaluation. So could you provide some insights why this may happening, some potential reasons for those huge difference?
Yeah, so I guess the huge gap, I guess one big part was they also rated the bounding boxes in addition to the design comments. And at that time, I guess the LLM object grounding was pretty bad. So I guess they took that into account with the rating. And then the human generated comments, they had perfect bounding boxes. So that's one reason for the huge gap. I guess another is we only fine-tuned it on 8 training examples. So we did a few shot on only 8 training examples, which is not a big number. Probably not enough to learn all the expertise they have for UI design evaluation.
Oh, I think thanks.
I'll just ask a quick one because I'm interested in this idea of your annotation. So you had a lot of feedback from expert designers, but expert designers are sometimes hard to find and use that to scale. So do you think that your rubric and approach is kind of clear enough so that you could kind of scale it up with what people think, or do you think that would lead to higher variability?
Yeah, I guess we do provide the raters with design guidelines. So I think maybe providing more of that or a simplified version could help with people without much design experience to provide the evaluation. Yeah, I guess rubric. Yeah, I guess if you also break it down to very specific characteristics and explain each thing carefully, it's possible that novice designers could also use it pretty well to give decent feedback.
Okay, cool. Thank you.
Okay, thanks.